Graphing using intercepts. To start us out, this picture here is actually a toilet paper roll, and this is some toilet paper roll art. They made little cuts on the inside of the toilet paper roll and folded some of the cardboard up to make kind of a shadowy looking design that I think is pretty cool. So graphing using intercepts. The x-intercept is the point where your graph or where your line crosses the x-axis. Conversely, the y-intercept is the point where your line or your graph crosses the y-axis. Let's look at the x and y-axis. Your y-axis is your vertical axis. Your x-axis is your horizontal axis. Every single point on your y-axis, well, let's look at a few of them. Here's the point 0, 5. Here's the point 0, 2. Here's the point 0, negative 3. Everything on the y-axis has the ordered pair 0, comma, some y value. Conversely, every single point on the x-axis, let's see, that's negative 5, 0, negative 2, 0, 1, 0, 3, 0. Everything on the x-axis has the ordered pair x, comma, 0. This is going to make it really easy for us to find our intercepts. To find the x-intercept, we're going to find x when y equals 0, since all the y values are 0 when you're on the x-axis. Conversely, to find the y-intercept, you're going to find y when x equals 0, since all the x values equal 0 on the y-axis. Find the x-intercept and the y-intercept of 2x plus 7y equals 28. Easiest thing to do is set up a table, and you're just going to let x and y take turns equaling 0. So let's see, if x is 0, 2 times 0 is 0, so that goes away. 7 times a number is 28. Let's see, divide both sides by 7. And y equals 4. So I have one ordered pair, 0, 4. For my y-intercept, I'm sorry, that was my y-intercept there. Since x is 0, that's the y-intercept. And I'm going to abbreviate that y-int. For your x-intercept, or x-int, you have a y value of 0. Let's try that out. If y equals 0, 7 times 0 is 0, so that goes away. 2 times some number is 28. Let's see, divide both sides by 2, divide by 2, and and x equals 14. So now you have two ordered pairs to graph, and you can graph this equation. Try this one on your own. Pause your video at this point and see if you get the same answer I do. Did you get ordered pairs of 0, 8 and 6, 0? If you did, draw a unicorn on your paper. If you did not, go back to the last example and try again. This also helps us with graphing equations. We're going to graph this equation and label where our graph crosses the x and y axis. So again, I'm going to have a little table labeled x and y, and I'm going to let x and y take turns equaling 0. If x equals 0, I have the equation 2y plus 4 equals 0. Subtract 4 from each side, and that leaves me with negative 4. I'm going to continue down here. Leaves me with negative 4 equaling 2y. Divide both sides by 2, and y equals a negative 2. So I'm going to go ahead and graph that ordered pair for the y-intercept, 0, negative 2. For the x-intercept, y is going to equal 0. So 2 times 0 is 0. So this one's quite a bit easier because x simply equals 4. So graphing the ordered pair for 0 will give me this ordered pair here. Typically, I want you to have 3 ordered pairs when you are graphing. However, if you're graphing using your intercepts, you're much less likely to make a mistake, so I'm okay with you just using 2 ordered pairs. So draw your line through your 2 ordered pairs and make sure you show that that line extends infinitely. Your turn. Find the x and y intercept and graph the equation. Pause your video at this time. Did your table and your graph look like this? If it did, draw a curly-haired Mrs. Peters smiley face. If it didn't, go back to the last example and try again. For homework, you have 2 problems. First, you need to say or tell, is it possible for a line not to have an x-intercept? And then you need to explain. Your second problem, you need to do the same thing for the y-intercept. Is it possible for a line not to have a y-intercept? Explain. Again, these are lines, so these are linear things. So you're checking to see whether it's possible to have for a line to not have an x-intercept and for a line not to have a y-intercept. See you tomorrow.